Hello, today's lesson is about proving triangles congruent in a coordinate plane. So basically we are applying our concepts from Unit 1, midpoint, slope, and distance or length, and we are combining that with congruent triangles. So to the next page. So in this one, let's just do a little refresher, and we want to find the slope between these 2 points and the length of the segment between these 2 points. So I'm just going to start with my slope, and I'm going to start down at the bottom and count up. 1, 2, 3, 4, 5, 6. You should be doing this too. And then I'm going to count over. 1, 2, 3, 4. So I can write my slope down, and I need to pay attention to whether this segment has a positive slope or a negative slope, and that is a positive slope. So my slope is going to be 6 over 4, and it's positive, and that should simplify to 3 over 2. So my slope is 3 over 2. Now it's also asking for the length. So to do the length, I'm just using Pythagorean theorem now that I've done the counting and I have my A and I have my B. So I'm doing 6 squared plus 4 squared is equal to C squared. And I'm going to work that out on my calculator. And if you don't have one, grab one or use your phone, turn the long way. And when you work that out, we get this to be square root of 52. Simplified would be 2 square root of 13, which you don't have to do. And decimal value is 7.211. And any one of those answers is fine. If you need another moment to finish, please pause the video. I'm moving on to the next page. So here we go again. We want you to find the slope and the length of this segment, that is here. So please pause the video here to complete the slope and length. Here are the answers. I got the slope is -1/2, and I got the length to be the square root of 125, or 5 square root of 5, or 11.803. So if you did not get those correct, please pause the video here to figure out how to correct your mistake. Moving on to the next one. So that was all prerequisite. That was just reminders of what we're going to use in order to prove triangles congruent. So what we're going to do is we're going to find the lengths of the triangles on the coordinate plane, and that's how we're going to decide if the triangles are congruent or not. So right now, what I would like for you to do is I would like for you to actually find the length of segment AB, the length of segment AC, the length of segment CB, the length of segment XY, the length of segment XZ, and the length of segment ZY. So we're doing exactly the same things we did before. We're counting up and over. I'll do AB with you. So from here we count up 2, and we count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so to find AB, or the length of segment AB, would be 2 squared plus 11 squared. And that should be equal to AB squared. So go ahead right now and pause the video and actually calculate each of these 6 distances, please. Here are my 6 lengths. So please check your answers. My answers are in purple. And if you have any mistakes, please pause the video here to correct those mistakes. So now what we're going to do is we're going to go ahead and mark our diagram with what we know. So I know that AB, which is square root of 125, and XY, which is also the square root of 125, are equal. So I'm going to put a slash on AB and a single slash on XY. Then I know that AC, which is square root of 32, is equal to XZ, which is the square root of 32. So I'm going to put 2 slashes on AC and 2 slashes on xz. Finally, I have that CB is the square root of 53, and XY is also the square root of 53. So I'm going to put 3 slashes on those two segments. So now I'm looking at my picture now, my diagram, and so the first question that I've skipped over, are their lengths the same? And the answer to that is yes. All of the 3 corresponding lengths are the same. So what method proves these 2 triangles are congruent? And when I look at the picture, I can clearly see that I have side, side, side. I have 3 sides in one triangle congruent to 3 sides in another triangle. So that is your first proof of 2 triangles congruent in the coordinate plane. So let's go ahead and look at the next one. So in this one, again, what I would like you to do right now, we have this picture in the coordinate plane, and I want you to find some more lengths. So can you find the length of segment AB, the length of segment CB, the length of segment XA, and the length of segment XC? Please pause the video here to find those lengths. Here are my 4 lengths. I found that AB is the square root of 58, or 7.615. I found CB to be the square root of 52, or 2 square root of 13, or 7.211. I found XA to be square root of 52, which is also 2 square root of 13, which is 7.211. And I found XC is square root of 58, 7.615. So again, I'm going to mark my diagram. AB is the square root of 58, and that is the same as XC. So AB, I'm going to put a single slash on, and XC, I'm going to put a single slash on. Then I'm going to do the same with the other 2. I have CB is square root of 52, and XA is the square root of 52. So I'm going to mark CB with 2 slashes and XA with 2 slashes. So are these lengths the same? And the answer to that is yes, they are. And so what other method proves these triangles congruent? Well, I missed something. I missed this one right here. Why don't we need to find the length of segment AC? And we don't, because this segment is in both of the triangles, so I can just start off by putting 3 slashes there, because I know it will be congruent in both triangles. So now, once I look at my diagram, what method proves these 2 triangles congruent? That method is side, side, side. So now I need to complete my congruence statement. So I need to make sure I'm matching things up properly. So let's look at A. A is right here, and this is for ABC, the upper triangle. And so A is connecting B with C. Okay, so it's connecting this red and this green. In the lower triangle, the green is already drawn in, the red is right here. So A is actually going to match with C. So let's look at our next letter, B. B in the middle, B right here, is connecting a red and a blue. So let's look at our bottom triangle. We have our red segment already here, and then our blue segment is this one. So B should match up with X. And finally, we have C again. So C over here, that I'm now coloring green, is connecting the green and the blue. And that's actually going to match up with A, which is connecting the green and the blue. So triangle ABC should match up with triangle CXA. On to the next one. So again, we're looking at these triangles in the coordinate plane. So the first thing that I would like for you to do, I'd like you to find the length of segment AB and find the length of segment BX. I'd also like you to go ahead and find the slope of segment AX and the slope of segment BC. So please pause the video here and find these 4 items. Sorry about that. So here we have AB is 10, BX is 10, the slope of segment AX is -1, and the slope of segment BC is -1. So now we need to answer these questions. Are the lengths the same? Well, some of them are. Let's mark them. So if I mark what is congruent, I know AB and BX are congruent. So I'm going to just put a slash on AB, and I'm going to put a slash on BX. So yes, we've got some. Now, there's one other thing I should go ahead and mark in my diagram, and that is segment BC is congruent to itself, because that segment will be in both of the triangles. And then it says, what do the slopes tell you? So what do the slopes tell you? And again, we're going back to the first unit, and we're also going back. Sorry, I wrote this one down wrong. BC as a positive 1. Sorry. Make sure you change this. This is a positive 1. We also assessed this on the Unit 2 test as well, but these slopes are opposite reciprocals. So that means that segment BC is perpendicular to segment AX. So what does that mean? That means I've got some 90-degree angles. So I'm going to put those in my picture. I have a 90-degree angle here. I have a 90-degree angle here. So from this point, I'm looking to see, well, do I have a right triangle, so I'm looking, do I have an HL? And so I'm looking for a hypotenuse, which this is my hypotenuse, and this is a hypotenuse. And then I need two legs congruent, and this leg is in both of the triangles. So this method is hypotenuse leg. And then let's just make sure we match up the letters. A is going to be congruent to X. B is going to be congruent to B in both triangles. And C is going to be congruent to C in both triangles. So triangle ABC is congruent to triangle XBC. So we have one more to do. And again, I would like for you to right now find the length of segment BC, the length of segment AC, the length of segment CX, and the length of segment CY. Please pause the video here to find these lengths. Here are the links that I found. So if you made a mistake in one of these, pause the video and make your correction. So I'm going to start out by just marking the things we know are equal. The length of segment BC is the square root of 58, and the length of segment CX is also the square root of 58. So I'm going to put a single slash on those two. And then I know the length of segment AC is the square root of 74, and the length of segment CY is the square root of 74. So I'll put two slashes there. So are these lengths the same? So far, so good. The ones we found, our corresponding ones, do match up. Next question. What do you know about angle ACB, this angle right here, and angle XCY? XCY is this angle right here. And I know two things. I know that they are vertical angles. And the other thing is I know the relationship for vertical angles, and that is that they are congruent. So I can mark that these angles are equal. So now, looking at my picture, what method proves that these two triangles are congruent? And I have an angle included between two segments, and I have an angle included between two segments. So that gives me side, angle, side. Now I need to be sure and match my letters up. And A over here should match up with Y in my second triangle. And then B in the first triangle should match up with X in the second triangle. And finally, C should match up with C. So triangle ABC is congruent to triangle YXC. So please, if you have any questions, bring those to class. Otherwise, have a wonderful evening.